Class, what's up? It is review time. All right, we have our logarithm test coming up in a few days. This will also be really good review for the final exam. But this is basically everything that we've covered in one video. I want you to rewatch. I want you to try and make sure that you understand all of these concepts. All right. So, we're going to start with graphing. Exponential graphs. We have to remember growth is when the base is greater than 1. Decay is when the base is between 0 and 1. Alright, so a lot of times we'll say this is a fraction. Alright, but that's what we're looking for. And we know how to graph these. Remember, I ask you guys to plug in some nice values for my exponent that we can work with very easily. And those values are -1, 0, 1. So when I plug them in, 2 to the 0th is 1, 2 to the 1st is 2, 2 to the -1st is 1/2, and we can now just plot those points. So 0, 1, 1, 2, and -1/2. And we then know that our graph will look something like that. Of course, there needs to be a horizontal asymptote. Alright, what happens when we change and now we look at something like decay? Well, I ask you to do the exact same thing. Right, still -1, 0, 1. When I plug in now, though, 1/5 to 0 is 1. 1/5 to the first is a fraction, 1/5. And 1/5 to the -1st is that whole number 5. So now we notice when we plot -1, 5, 0, 1, 1, 1/5, something like that, this is what we now call decay. Alright? So what I need you to understand from this is that growth is moving away from the x-axis, decay is getting closer to the x-axis. Now, exponential graphs are always asymptotic to horizontal lines. And really what I want you guys to do for the points, I want you to always find me -1, 0, 1. Alright, that's what I always want you to do. Now, when we move on from exponents to logs, slightly different. We have to remember that logarithms have a domain restriction, okay? And that happens because we cannot take logs of negatives or zeros. Alright? Now once again, and I don't think I talked about it a ton in the last video, but again, growth, if the base is greater than 1, that's growth. If the base is between 0 and 1, that would be decay. So let's take a look at what that looks like. Again, what I will do is I will want to make a little table. I don't know if you guys remember, and it's up to you. I just feel more comfortable if I change this to y equals log base 5 of x, and then I change to exponential form. I know that this is the same thing as 5 to the y is equal to x. Alright? So the reason I do this is because now when I make my table, I know that I'm still able to plug in these nice exponent numbers, but they're no longer x values, they're y values. Alright, so now when I plug in 5 to the 0 and get 1, it switches spots, right? Where this will be 5, this will be 1/5. And now, how does that look when we graph? Well, 1, 0, 5, 1, 1/5 -1. So we see that this becomes a different looking graph. In fact, what happened? My asymptote went from a horizontal line, to a vertical line. And the points that I was finding, they switched. No longer were the -1, 0, and 1 in the x column. They are in the y column now. Alright? So now let's take a look at this last one. And remember, I'm going to switch this, and I know I don't have a ton of room. I'm going to do this down here. Remember now, I am no longer doing 1/3 to the x equals y. I'm doing 1/3 to the y is equal to x. Alright, so in my -1, 0, and 1 go in the right column. I plug in some numbers, so I have 1, I have 1/3, I have +3, right? 1/3 to the negative first is +3. Good. So now when I plot, let's see here, I have 1, 0, I have 1/3, 1, I have 3, -1, and now I can see why we call this decay, because it is going down. Finish up with an asymptote, and we should be good with this page. Alright, so there's a brief rundown on basic graphs. Now let's flip over. We're going to talk about inverses for a second, and then we're going to get into some transformations as well. Alright, so one thing that we need to remember is that exponentials and logarithms are inverses of each other, okay? So logarithms. Inverses of exponents are logarithms. Inverses are reflections of each other over the line y equals x. And one thing that's nice that you can also always do is you can switch x and y. Now, that is going to be more, at least in this chapter, that'd be more like a testing option, switching x and y. So let me run that down for you real quick. So if I have x comma y, and I want to graph y equals 3 to the x, well that means I have an exponential, and I want to put my x values, or my nice exponents, in the x column. So I get 1, I get 3, I get 1/3. When I take a look at this one, I'm going to switch. I'm going to say I have 3 to the y is equal to x. So now, ooh, you know what? I should have changed colors. I'm going to change this, guys. Sorry, my bad. I'm going to make this red. When I continue x, y, remember now my -1, 0, 1 go in the y column. And so I get 1, 3, and 1/3. And this is what I was talking about, guys. I already know without graphing that this is going to be right, because what happened with all of my points? I had -1, 1/3. Now I have 1/3, -1. I had 0, 1. Now I have 1, 0. I have 1, 3. Now I have 3, 1. Alright, so that already tells me that the x's and the y's switched, so these are nice. Now graphically, we should finish this up, because I want to show you guys and make sure you're aware that they should be exactly reflected over the line y equals x that I just dashed in. So let's go purple over here, and let's plot 0, 1, 1, 3, -1, 1/3, sketch it with a horizontal asymptote, and now let's go red. So let's go 1, 0, 3, 1, 1/3, -1, sketch it, and oh my gosh, what do you know? Maybe not the best drawing, but I would agree that these look pretty well reflected over that line y equals x. Okay? And that's what you're looking for. That is what you're looking for. Now when we get on to transformations down here at the bottom, what I want you to remember, and it's kind of up to you, if you would like to graph the very basic function and then perform the transformation, I am okay with that, if that's what you feel comfortable with. I personally want you to find whatever the base function is, okay? So if I see y equals 4 to the x minus 2, well I know that the basic would be y is just equal to 4 to the x, but then I want you to list the transformations. So because this minus 2 is with the x inside the function, that minus 2 means right 2. And what I mean by that is that I'm going to take care of this transformation right now before I do anything else, because I normally start at the origin, 0, 0. Well, if I have to go right 2, I'm going to move my starting point 2 units to the right. Alright? And now it turns into a standard problem. I know that I have an exponential, so I know my -1, 0, 1 is going in the x column, and I plug in 1, 4, 1/4, and here's the trick, right? you need to plot these points from your new origin, or from your new starting point. So 0, 1, 1, 4, negative 1, 1/4, and we sketch. And we make sure we put in our horizontal asymptote. Okay? So what happened? A graph that used to be centered at the origin is now centered at 2, 0, because I knew that I had to shift 2 units to the right. Now, same type of idea on this log over here. My basic would just be y is equal to log base 2 of x. But what do I know is happening? I know that I am going 1 to the left because I have a +1 inside the log function, and I know I'm going 2 down because I have a -2 outside of the log function. So what do? I immediately mark my new starting point. 1 left, 2 down. 1 left, 2 down. I now know that everything I'm going to plot is going from that point, not the origin. So let's make a table. This is a log, so if we remember, if I move this stuff around, I'm not doing y equals log base 2 of x. I'm going to do 2 to the y is equal to x. So that's my hint that I need negative 1, 0, 1 as my y column. And now I can plug in, excuse me, 1, 2, 1/2, and I plot all those points. So 1, 0 from my new origin, 2, 1 from my new origin, 1/2, negative 1 from my new origin, and I also need to make sure that I plot my vertical asymptote, because now I know that this graph should look something like this. Alright? Okay, I think, let's hope, yes, okay. We're done with graphing for a while. That was a lot of graphing. I'm sick of graphing. I don't know about you guys, but I am. Alright, let's move on. I like solving more anyways, right? Alright, well, let's start solving a bunch of problems. Some of them will be nice and easy, some of them will be a little tougher. Let's see what we got. Okay, what do I notice in number 1? Ooh, I have the same base, but what is the problem? I do not have any simplification or exponent rules when I subtract 2 exponents from each other. Okay, so that is my hint, or I should start to understand that if I can't do anything to combine the exponents, well then I'm going to have to use a substitution. So a is going to equal e to the x. I'm going to want to rewrite this, right? 1 over e to the x. And now I can substitute. A minus 1 over a equals 6, or when I multiply everything to clear the denominator by a and distribute, I should get a squared minus 1 equals 6a. So now we move this over. Let's see what we have. Ah, shoot. I don't think we can factor that, which means we have to do our favorite, you guessed it, quadratic formula. Alright, so a is going to be equal to opposite b, so positive 6 plus or minus square root of b squared, so 36, minus 4 times 1 times negative 1, all over 2. Keep cleaning. A is equal to 6 plus or minus, well, now this is going to be the square root of 40. Okay, 36 minus negative 4 is 40. I know that I can take out a perfect square of 4 from 40, and the perfect square of 4 is 2. So square root of 40, if I look at this and break it down, I should break it into the square root of 4, the square root of 10, and I know square root of 4 is 2, so 2 root 10. Now, these are all over 2. Let's just split it up now so we don't forget that we have to just that 2 acts on both pieces. And now I should see that a, when I come back up, should be 3 plus or minus root 10. Now we're completely done, right? No, we are not done. I don't care about a, I care about x. If I'm solving, I want x, not a. So now I plug back in 3 plus or minus square root 10, and then at this point in time, because my because my variable is in the exponent, I'm going to want to switch to log form. So I have an e, which means I'm going to go natural log of this entire right side. 3 plus or minus root 10 is equal to x. Last thing you have to do is check for extraneous, okay? Now, nice and easy on the top. 3, which is positive, plus another positive, that's going to be positive. What we have to do is we have to figure out if when we subtract root 10 from 3, if that'll be negative. And hopefully you agree with me when I say that yes, it will be negative. Why? Root 10 is just a little bit bigger than root 9. And root 9 is 3. So if root 10 is 3 point something, and we're taking it away from 3, well, that means that that means it's going to be negative when you take it away. So to finalize the answer, we recognize that the negative or minus option is extraneous, which means my only option is 3 plus root 10, ln of 3 plus root 10. Okay? Nice. Again, just to kind of sum that up, how did I know that I needed to use a substitution? I don't have exponent rules here. I do not have exponent rules here. What about on this next one? Let's take a look. Let's clean this up as much as so I have 3 to the 4x times 3 to the x squared. Ooh, 3 in the bottom. I can bring that to the top. Okay, this one looks a little nicer to me, and just right off the bat, I know I can keep going. Why? Because I have a multiplication sign. I know when I multiply common bases, I can add the exponents. So this will be x squared plus 4x equals 3 to the 12th. Perfect, right? Because now we have common bases. We have two exponents, same base, equal to each other, which means the exponents have to be equal. So this is nice and easy, guys. Keep going. Keep going. What do we got? X plus 6, x minus 2. So x equals 2, x equals negative 6. That should be good. How did I know that I didn't need to check for extraneous solutions? Okay, this actually goes back to even our graphs. We know that when we graph exponential functions, there's no restriction on the domain. Okay, there's no restriction. It's all real numbers for domain. So that's why I don't care if you're 2 or negative 6 or negative 1 million or the square root of 5 trillion. Like whatever your x value is, you're good in exponents. All right, let's move on. Let's check out something like number 3. All right, similar type of problem. I see lots of e's. So I have e to the negative x squared is equal to, okay, let's go e to the x. Let's change this to e to the negative 3. I think that'll be a little easier for us to notice and work with. Because now I see that I have e's as all of my bases. I can still clean this up a little more because of that multiplication sign, which is really nice. So e to the negative x squared is equal to e to the, I can combine these, right? X minus 3. Excuse me. Now I see I have the same base, so I can set the exponents equal. Now, I want this to be positive, right? I like my a value to be positive, so 0 is equal to x squared plus x minus 3. This is a problem. I cannot do it, so we need to quad form. X equals negative 1 plus or minus the square root of 1 minus 4 times 1 times negative 3 all over 2. So x equals negative 1 plus or minus 1 plus 12. Okay, square root 13. I can't do anything with that. So you know what, guys? We're done. Negative 1 plus or minus the square root of 13 all over 2. Not that bad. Let's keep moving. I want to get through these and not spend too much time and waste too much of your own time, okay? So let's keep going. I have a log here. We know that when we have exponents, I keep saying exponents, when we have variables inside the argument, we want to get them out of the argument. And to do that, we need to change the form. So we log circle, right? 2 squared equals x squared minus 2x minus 31. Well, I know I'm going to want to move that over, so I'll have 0 is equal to x squared minus 2x minus 35. Right? Because that's just 4. Moved it over. And now, ooh, this is a good one. We got this. How do we get from factors of negative 35 to negative 2? Well, x and x, I'm going to have to go down 7 and back up 5. Alright, down 7 and back up 5. So now I know that x must equal negative 5 or 7. Please make sure to check for extraneous solutions. When we do that, let's see, 25 plus 10 is 35. Okay, so we're good on the negative 5. 7 squared, 49, minus 14 is 35. 35 minus, okay, we're good on both. We can box both of our answers. Let's keep going. Alright, this next one. Don't stress out about it. I know it's lots of ln's. I know we don't like ln as much as log, but please remember it acts the same way as a log. And please remember that when we have multiple logs on one side, it's a good idea to combine them. Alright? Let's take a look. ln, how do we combine logarithms when they're split by addition? Well, we multiply the arguments. So I can distribute. So I have x squared minus 4x. And that's equal to ln of x plus 6. So now I know, because I have two logarithms set equal to each other, the same exact base of e, well then the arguments have to be equal. So x squared minus 4x must equal x plus 6. Now to clean this up, I need to move everything, to solve it, I need to bring everything to one side. So I'm going to leave this over here, I'm going to move an x, and I'm going to move a 6. And now we can factor. X and x. I think I'm going to have to go down 6 and up 1. Perfect. And so now I know that x should be negative 1 or 6. Please make sure to check for extraneous solutions. Right off the bat, I see this ln of x. So that means that I cannot have any negatives in my solution, which means negative 1 is out. And my only answer is x equals 6. Alright. Okay. For the next one, I see an exponent. We really can't solve this exponent yet because there's more stuff going on. Alright, so what I need you to understand is that you should always do as much algebra as possible before you start trying to switch from exponent to log or log to exponent, okay? Like I know that I can, because there's multiplication, I'm just going to divide both sides by 18. So I have 2 to the x is equal to 7 over 18. Now I just have an exponent on the left side, so now I can go ahead and convert to log form, which means I'm going to use log base 2 of 7/18 and set that equal to x. And guys, I would leave it just like that. I don't want you to guess. I want an exact answer. So there you go. Whew, okay, final page, I think. Yes, last page. Alright, good review here. Domain. We have a couple domain problems that I want us to go over. Please remember, the whole idea here is that the argument of log must be greater than 0. Okay, the argument of a log must be greater than 0. Now, the argument is anything inside of the log. So this whole thing is the argument, right? X plus 5, x minus 9, and that's all set greater than 0. Now, this goes right back to last chapter. So this is good review. This is a rational function, basically. And we're using an inequality. So we need to plot a number line, graph a number line, and plot the critical values. Okay, we need to plot the critical values. Well, I have a critical value at 9, because if I were graphing this, I would have a vertical asymptote at 9. I would also have a critical value at -5 because -5 is an x-intercept. It's in the numerator, that's an x-intercept. Now I'm going to put bubbles there, and I need to decide, do I keep them open or do I close? Anything in the denominator, of course, will be open because that is a vertical asymptote, and you cannot ever hit or touch a vertical asymptote. Now -5 is different. -5 or anything in the numerator, that one you have to kind of question, and we usually look at the sign. The reason is because if I actually plug in -5, it makes this entire side 0. And is 0 greater than 0? No, it is not. So you cannot count -5 in the actual solution. Now we test our sections. Plug in any negative value lower than -5. How about -10? -10, let's see, that's going to be negative over a negative. Okay, so negative over negative is positive, that's what we're looking for, so we shade. Plug in 0, or anything in between. Positive over negative, nope, that's negative, I don't want that section. And lastly, how about 10? 10, positive, positive, okay, we're good. Now we know that our domain will be from -infinity to -5 open, union open, 9 to infinity. And there we have it. Alright, we have another domain problem. Please remember that when you're looking at these domains, you have to forget everything else except the argument. I don't care about the 17, I don't care about the 11, all I care about is the argument. And I know that x squared minus 4 must be greater than 0. Well, when I factor, I now see my critical values. These are x-intercepts, right? Because they're in the numerator. So I would graph a number line, and I would plot my intercepts. And because it's greater than 0, I know that I'm going to be open circles. Can't actually equal 0. Now we test. So, -5, for example. Negative times a negative is a positive. That's what I want. Plug in 0. Negative times a positive is negative. I don't want. +5. Positive times a positive is positive. That's what I want. And we now know then that the domain, oh, I'm goofing up, -infinity to -2, union 2 to infinity. Alright, couple more problems, almost done. We're getting there. I'm sorry this is taking so long. Okay, number 9. Number 9. Okay. I have an exponent, variable stuck in the exponent. I want to go to log. I want to switch this to log. Now, because my base is e, I'm going to say the natural log of 1/3 is equal to -2x. Now, I'm going to divide both sides by -2. So ln of 1/3 over -2 is equal to x. I will be very honest. At this point in time, I'm pretty close to being okay with this answer. This is a correct answer. I just think I would rather it be simplified a little more. Okay. By that I mean, like, we hardly ever leave negatives in a denominator, right? Like, at least I would change this to x is equal to negative ln 1/3 over 2. The last thing that I would like you to eventually see, and again, I don't know if I'm going to count off for it right now, is that because I have this negative out front, I think it would actually make the argument way nicer if I treat it more like this. Okay, and move my -1 up into the argument's exponent. So something like this, ln of 1/3 to the -1st over 2. Okay, so when I do that, I can go like this and make it look a lot nicer. Again, guys, this is not something I expect. I'm giving this to you basically the last day before, or a couple of days before the test. So this isn't something I'm expecting, but it's not bad, and it's good math, and it's good to understand why I did that. Alright, so that's why I did that. And we're finishing up with one final logarithm problem. I hope you guys are okay and recognize that I have multiple logs. I probably want to try to combine them if I can't get them to be equal to each other. And I know I can't get them to be equal to each other because of this little 1 here. Okay, that's messing everything up. So that means I'm going to need to try to combine, which means I need to move log base 8, sorry, x plus 6. And I'm going to move this guy over to the other side. So log base 8, x plus 4, and that's all equal to 1. This goes back to what we did earlier, guys. We know that when we have 2 logs, same base, with addition between them, we can combine using multiplication of the arguments. So x squared plus 6x and 4x, that's 10x. 6 times 4 is 24. All right, this is looking good. And now because I have variables in an argument, I'm going to log circle or convert to exponential form, which means 8 to the first is equal to x squared plus 10x plus 24. And 0 equals x squared plus 10x plus 16. So lastly, I go and I factor. What do we got there? Plus 8 plus 2. So x should equal -2 or -8. Now, please, 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 of course, make sure that you check for extraneous solutions. -2, normally negatives aren't good, but -2, when I plug it in, that goes positive, so -2 is fine. -8, however, is not okay. -8 is not okay, it's extraneous, so I finish by saying x is equal to -2. Alright, so that was a little longer than I wanted. I think that is a good rundown of what I'm expecting from you guys. I hope all of this made sense. Happy studying. See ya.